Hey, section 5.2 is about normal distributions. We're going to spend most of the rest of this course talking about normal distributions and what we can calculate and what can we know about them. Let me kind of connect this a little bit to chapter 2. In chapter 2, we did things, we calculated probabilities that are called discrete probabilities. When we were doing our frequency distributions and histograms. So discrete probabilities, they can be counted. That's how we define them. So for example, if I want to make a histogram of how many times I roll different numbers on a die. So my options in my sample space are 1, 2, 3, 4, 5, 6. And I can roll that and I can make a distribution and a bar chart or a histogram of those outcomes. That would be considered discrete because you can count all the options on your hands, okay, or more, you know. The other type of probability is called continuous probability. All right, and what happens in continuous, you can't really count all your outcomes. So let me give you an example. If we're talking about somebody's blood pressure, it turns out that there are an infinite number of blood pressures that somebody could have because we're measuring in decimals and there are an infinite number of decimals. They could have 20.1, 120.1 to 120.2, 120.3. There's all of these options. And so to make a bar for each one becomes unrealistic. Okay. Now it's kind of a weird, the idea of countable and uncountable in math can be kind of freak your mind out a little bit. That can be a little hard to grab. What I just want you to understand is that sometimes we make a bar chart and sometimes we draw a continuous curve because there's so many options of outcomes that it doesn't make sense to draw individual bars. Okay, and we've talked about this a little bit before, and these, when we talked about measures of position, we talked about z-scores, and this is kind of what your normal distribution usually ends up looking like. Instead of drawing bars, we're drawing a continuous curve. But here's what I want you to understand about this is that we're still calculating the probability of the outcome. So we're still measuring how many times did something happen and what's the probability that we get a specific outcome. The curve looks like this. We're looking specifically today at normal distributions, and they are symmetric like this, and they have some properties that we're going to go through. You can have a distribution that's skewed. There's a lot of different ways distributions can come out. We'll look at one a little later. That's a horrible drawing. Okay, let me try that again. You can have well, we're going to look at one later in chapter 8 that kind of goes up heavy like this, and then it skews way out here to the right. That's a different kind of distribution, and that happens. But for the most part right now, we're going to focus on this, this normal distribution. So here are some properties of a normal distribution. It's continuous. Okay, you can see right here. And it has these properties. The mean, median, and mode are all equal. And they're all in the middle. They're all this middle value. Okay, and you can see here that that's labeled with our mu, which is our mean for our population. The normal curve is bell-shaped and it's symmetric. So that means there's an equal amount on the right and the left. And we talked about this when we talked about the empirical rule. Remember, there's 34% of all data points fall within one standard deviation of the mean on either side. Okay, and then I think this was 13.5, 13.5, and this is 2 and some change. It goes down from there, okay? The total area under the curve is equal to 1. So if you add up all of those all of the area under the curve, that's 1, because that's 100% of the time. Remember, we're talking about probabilities. The area under this curve is the probability that something occurs. So if you add up all of your probabilities, you should get 100%. So this curve is representing all the options. Also, the normal curve approaches, but it never touches the axis right here. So I know this looks like it's touching, but it's not actually. It just flattens out and hovers above there. My drawings are never that accurate, but that's technically how they're supposed to look. So if they don't look that way, I pretend like they do. And then the last point just talks about how each marker is 1 standard deviation away here. And we call this point and this point, which are 1 standard deviation away from the mean, we call those the inflection points. That's not super critical for our purposes, but it's a vocab word you can throw out in your files for what it's worth. Now, given all of these parameters for a normal distribution, these distributions can be fat or skinny depending on what the standard deviation is, and they can be anywhere on a number line depending on what the mean is. So here are some examples of that. These guys, if you can notice the number line below them, okay? So this first one has a mean of about 3.5. That's right here, that's the middle. And look at how wide it is. So it's wider because the standard deviation is about 1.5. So that point of inflection is 1.5 away from the mean, as opposed to, look at the second one, has a standard deviation of 0.7. So this has a mean still of 3.5. It's centered at the same place, but because the standard deviation is smaller, it squeezes that normal curve in. Now it's still symmetric. It's still centered around the mean, median, mode are all the same. It follows all those parameters, but the overall shape is just fatter or skinnier depending, okay? Also, in example C, we can keep the standard deviation same and move the mean. All that does is it's taking this graph B and it's moving it, it's scooting it down the number line so that it's centered around a different number. So that's how all of these will work. You can, we're not going to be super particular about what your drawings look like, how skinny, fat, but I want you to understand that that's what the standard deviation does, is it changes the skinny and fatness of a graph. Okay. All right, so let's talk about how to use these in the context of a problem. Let's say that the average height hold on, of a US woman is 64 inches with a standard deviation of 4 inches. Okay. If heights are normally distributed, draw a picture. Okay, we're going to always start with a picture. I think it's helpful to have a visual. So this is a normal curve. So I'm going to draw my curve and, just try to make it roughly symmetric. It doesn't have to be perfect. The mean is always going to be in the middle. Okay, average. I tend to use average and I use that interchangeably. I try to write mean. Your book always writes mean. So the mean height is 64 inches. That's in the middle here. Okay. The standard deviation is 4 inches. So that's where I'm going to plot. That's where my points of inflection are, is 4 away on either side. So that means it's going to be 68. and this is 60. Now you can label however many of these you want. You can go another 4 up and another 4 down. It doesn't matter, but that gives us kind of a grid for where the bulk of the information is. So that means to me, because of the empirical rule, I know that 64% of the US women then will be between 60 and 68 inches, okay? Now, what I can do with this is I can ask you a probability question. And because we're talking about the area under this curve, I don't actually have to build a fraction. I can use the curve itself to calculate the probability, which makes it a lot easier. So if I ask you now, find the probability that a random woman is between, let's say, 58 and 62 inches. All right, now I'm going to mark that on my drawing so you can kind of get an idea for that. 58, remember this line at the bottom is just a number line, so find 58. 58 is just a little bit on the left of 60, so we'll call this 58. And then 62, 62 is between 60 and 64. So what I'm looking at, what this question is asking is, what's this area? This area is the probability. So the numbers down here are your actual height values, but that area between your height values ends up being the probability. Now, in calculus, we learn how to calculate the area under that curve. But since that's not a prereq for this class, most of you have not taken calculus, we're going to do this problem on our calculator, and the calculator is going to calculate that area for us. So if you are on class calc, you're going to grab your numbers. So we've got a mean of 64 and a standard deviation of 4. So you come over here, you're going to find what you want under stat. And now we're going to go to this distribution plot. And here's where we find normal distribution. So that's what we're doing here. And on class calc, it prompts you right down here. This question mark always tells you what's supposed to go, what, like it's blinking, waiting for you to enter. And if you ever don't know, it's right here. So it says, put the mean in first. So that was 64. That was our mean height. And our standard deviation was 4. So then we're going to put 4 in the next spot. And class calc is really cool because it draws a picture for you. Okay. Now, sometimes when you put those numbers in, you don't see a picture. All that means is that your screen is off center. And the way that you center it is this little tiny magnifying glass below your box there. If you tap on that, it will center it for you and show you the picture. Okay. So that's the picture that we drew. Now, I want to know what's the probability of finding a woman with height between 58 and 62 here. So what you're going to do is tap over here on this CDF. I think C stands for cumulative. And I don't quote me on this, but I think it's like cumulative distribution frequency or something like that. So it's cumulative means the sum of, okay? So now look, the whole thing colored. So this is, look at the answer over here. This answer is 1. Everything that's colored is 1. The total area under this normal distribution is 1. That's your whole deal, okay? And look at what it says. It says negative infinity to positive infinity. That means the whole thing. Now, we don't want the whole thing. We want, I've already forgotten, 58 to 62. Yeah, 58 to 62. So let's enter those in. Right here is going to be the left side. The smaller number always goes on the left, 58. And on the right, I'm going to type in 62. Whoop, I didn't come over here. Sorry, 62. Now look at our picture. Isn't that cool? So you can kind of check yourself to see if you've got it right. And you can zoom in if you want. I lost it. Sorry, hold on. If you want to, you can zoom in, you can drag it over, you can see it up close, all that stuff. But down here is your answer. Now your answers are probabilities. So these answers will always be between 0 and 1, can't be more than 1. So the probability that a random woman is between 58 and 62 inches is 0.24. Typically we're going to round to 3 decimal places here. So 0.242 is what we're going to call it. Okay. And that's your answer. So I would say if I was going to try to communicate what I did, I'm going to say you're going to do normal distribution, and you're doing your mean, which is 64 and 4, and then you're doing your CDF is between 58 and 62. So that's what we entered on the calculator. Now, if you're on a TI, let's walk through that really quickly. Let me pull this down with where we are. Okay. So on a TI, you're first going to hit your second button and then this VARS button. What we're getting at is this distribution. That's the menu we want to be in. So second VARS, that's going to get you in your distribution menu. And the first one is normal PDF, and the second one is normal CDF. This is what you want, normal CDF. If you hit enter on that, it's going to give you a screen. Now, excuse me, depending on if you have an old or a new calculator. If you have a newer calculator, it's going to prompt you. It's going to say lower, upper, mu, sigma, paste. If you have an older calculator, it's just going to go, it's going to say something like norm CDF, and then it's going to have this parenthesis and just that's it. Okay. If you have an older calculator and this is what you're looking at right now, you want to write this down because that's going to be the order that you're entering your numbers, and you're going to need to remember that because it doesn't have a prompt. If you have a newer one, you have prompts. So what this is talking about, if I'm going to look at my picture again, let's label it here. This is your lower. Lower is left always, okay? 62 is your upper. So what it means by lower and upper is what's the lower end of the section you're interested in, and what's the upper end. So left and right. So you'd enter 58, 62, and then mean obviously this is your mean, okay? And your standard deviation is 4. And then you hit paste, and then that will give you your answer. 62, 64, 4. I think you have to hit enter twice and you get 0.2417. Okay. So that's how you do a normal distribution on a calculator. Now let's do another question off of this problem. The only way these problems change is the scenario changes. We're not talking about height. We're talking about, number of dogs people own or blood pressure or whatever. And the mean and standard deviation change. But the types of problems are always going to say, it's always going to say, find the probability that, and then it's going to give you some parameters. And you're always going to this menu. You're always doing the same thing. Okay, so I'm going to not worry about writing out a whole new problem. I'm just going to use the same mean and standard deviation, but I'm going to redraw my picture down here with a second part to the problem. Let's say, what's the probability that a woman is more than let's say 65 inches. So let's draw this picture again. My mean is in the middle. My standard deviation's 4 away. Okay, but now I'm looking at, I want more than 65. Okay, so that's right after 64. Here's 65. And more than is always to the right. Okay, so there's no upper bound, there's no right bound. It's like 65 all the way up to infinity. Okay, you're going to do this the same place on your calculator. Let's go check that out. You can use this same work you did right here, okay, because the mean is still 64 and the standard deviation is still 4. We're just going to change our little section right here. Okay, so I want to know what's 65 up. So my lower bound is the left part of my colored region. So the left side of the colored region is 65. The right-hand side is infinity. Okay, the left-hand side over here is negative infinity. So if it's to the right like that, then it's a positive infinity. So I'm going to say 65. And on class calc, if you just leave this empty, do you see that? It's kind of gray, light gray right there. That's an infinity symbol. And look at your picture. It looks like what we drew. So it's 65 all the way up. And your percentage is 0.40. Now let's talk about reasonability. Your mean is 64, right? Your mean's right in the middle, which is half. If the whole thing's 1, then half of it's going to be 0.5, right? So if I'm just a little above half, then 0.4 makes it makes pretty good sense that it's a 40% chance. So I'm going to say 0.40 is my answer, 0.401, 401. Okay. Now on class calc, we don't have an infinity symbol. So you're going to do the same thing. You do your norm CDF, okay? And your lower is just like on class calc is going to be, whoops. Your lower is going to be your 65. But for the upper, we just have to put a really large number in there. And the way that we do that on a TI is we're going to write E to the 100 power. So first of all, E is right here above the division sign. This is just a number to a real to 100 power, which is really big. So it's just a way of like writing 10 million easily. Okay, so the E button's here. So the way you're going to do it is get your cursor to be in the upper, to put your upper, do second function E. That division sign is going to give you an E. Your caret is right above it. That puts you in the exponent, and then just type 100. So it'll look E to the 100 right there. And when you do that, that will be, that'll give you the same percentage that we had, which is, what did we say it was? I lost myself, 0.401. So that's how you do the top end. Similarly, I can ask you about a less than, okay? What about what's the probability that a woman is less than, say, 58 inches? So now we're looking at, here's 58 here. Let's do this in yellow. Here's 58, okay? And less than is to the left. Bigger's to the right, smaller's to the left, okay? Maybe we should make a little chart of that. If I say more than, greater than, these are going to be a certain marker up. If I say less than or no more than, these are from a certain marker down. Okay, so that's how you draw your picture. Now, less is always on the left. So in this situation right here, this is your left bound or your lower bound. In this situation, this is your left or lower, and this is your upper. And here, this one is your upper. So it's always like you just look at it straight on your left. If your left hand is left hand and right hand are marking the section that you colored in, the left hand's the lower, the right hand's the upper. So for this problem, this yellow section, my left or lower bound is going to be negative infinity, and my upper bound is going to be 58. So on a TI, you're going to write, now it's going to look like this. We're going to write negative infinity, or in our case, we're writing negative e to the 100. Now, be careful. On a TI, negative is not minus. The negative button is right here. Okay, so it'll say error if you use that minus sign. That's not a negative. So I'm going to go negative, and then I'm hitting my second function and my e above the division, and then my caret and 100. That's my lower bound, and then my upper bound is my 58. That's right there. Okay, on class calc, lower bound, I'm just going to leave it empty, and when it's empty, look at what it says right there, negative infinity, okay, to 58. And then you can see, I really like class calc for these problems, because if you draw a picture, which I'm going to have you do for all of your problems, when you draw a picture, then you can check it on the calculator to see that you entered it right. Like if you accidentally put the 58 on the wrong side, then you go, oh, wait, that's not how I drew my picture, right? That's kind of a check for yourself. And then you go, oh, I must have put that in wrong. And so you can almost like guess and check with class calc a little bit until the picture looks like you know it's supposed to. So probability that a woman's less than 58 inches, that's going to be 0.067. So it's pretty low. So we're going to say 0.067. The last thing we want to address in this section is what it means for a value to be unusual. If I ask you for what is the probability of something, and your answer is less than 0.05, then we would consider this unusual. Okay, and what that means is, if you look at your normal distribution, our typical answers, our usual answers are in this main part of the curve. So any region in that big part is what we would call a usual or a typical answer. But these tails are unusual results. So that's where you find the extremely tall people, the extremely short people, you know, the people with the extremely high test outcomes or extremely low test outcomes, that sort of thing. And so we can judge that not only by how many standard deviations they are away from the mean, but also what the probability is. Since we're figuring out the probability anyways, anything less than 0.05, we're going to consider that to be unusual. Thanks for tuning in. I'll check with you next time.